All right, so it's now time to talk about how these in-context blend shapes that I just created for the ankle fix are going to be triggered. Let me make sure this second one is off. So one of the first things I knew I had to do was make sure that the triggering is happening with my resultant chain, because moving the foot as I have done right now, if I rotate this foot 35 degrees in IK mode, that does not trigger the FK version of the foot. So the FK version of the foot is still straight. And I need both FK and IK to trigger this fix. So that would mean that the way to get around this is to use the resultant chain or the resultant joint chain to trigger this blend shape. So let's turn the joints on and let me show you something. So with the joints now on, this is a resultant chain that Advanced Skeleton gives you, and it really is under their deformation system here. And this chain is what both the IK and FK control. So if I switch back to my FK mode, it resets this resultant chain, but it's the same one. You can see I'm selecting pretty much the same thing. And if I rotate it, it now re-rotates it. So you would basically have to match IK and FK to get them to be doing the same thing. But every time you switch back, it gives the charge to the other joint chain or the other control system, FK or IK. So long story short, it's important that we use this resultant chain to trigger the blend shape. But when I went to take a look at whether or not this chain is receiving any rotation values, take a look. It's not receiving any values. So even though I've rotated this 40 degrees, so I might as well make it 35 too, say 36, sorry, negative 36. The resultant chain is not receiving any values. And if I go to IK, same thing, right? It has rotated the resultant chain and it's not receiving any values. Now, if you remember back in lesson 5, the end of lesson 5, I gave that whole speech about how when it was time to build this whole thing, I was not going to have the offset parent matrix option checked right there because I was having issues with my numbered IK label not building completely. So for the entire rig, I had this unchecked. But if you remember in lesson 47, I did a rebuild of this entire thing. And when I did that rebuild, it didn't occur to me that I had offset parent matrix checked. And the reason why I did that rebuild is because Advanced Skeleton put out an update. So it looks like in that update, the issue was resolved because now the entire rig relies on an offset parent matrix connections for constraining. So that is one of the reasons why you're not going to see any values over here. So where are we going to be able to pull the values for this resultant chain from? And the simple answer is the offset parent matrix values here. But the thing about these offset parent matrix values is that they're not directly accessible to the set-driven key system. They're not like your typical transforms. So if I was to open the set-driven key window and I was to try to load this resultant joint in as a driver, now I have show all non-keyable selected, but if you open this window, you would probably have this unchecked. This is all you have. You have access to keyable transforms. And even if you wanted access to non-keyable parameters and you checked this, show non-keyable parameters, you're not going to find any of these matrix values in here. They're not accessible. So that adds one more tier of complexity as far as how we're going to access these values. But on a good note, it's not too complex. It's just going to require us to go into the node editor. So let me open the node editor. So I have this ankle mapped. All I did was just select it and hit the map button here. And there it is. So when you want to utilize offset pair matrix values, one other way to gain access to them is with a decompose matrix. Now you see me do some fancy stuff with the offset pair matrix when we were setting up the cut up meshes, and you saw me try some constraint systems and use a few of the matrix nodes available. I think we used the mult matrix. And I think initially I also confused it with a sum matrix. But now here we want a decompose matrix. And what that does is that it takes these rotation values and turns them into something that we can read or use in operations. So if I hit tab, this is what I'm talking about, decompose matrix, this node right here. But this is a little messy. I don't want to set this up in this scene because whenever I come in here and I set up a decompose matrix like this, I want to make sure that I create it in a window that's later accessible. So I want a nice clean sheet to use. So I'm going to clear the graph. And I'm going to grab both of these joints because they're going to be used as triggers right now. And I'm going to add them to the graph. And there they are over there. All right. And when I'm done with what I'm about to do, I will store this connection sheet as a bookmark so I can come back and access it later, because from here on out, whenever I use this method to access offset pair matrix rotation values, I'm going to do them in the same sheet so I can come back and find them in the same place so it's easier to edit them. Because if you try to look for this by simply just mapping any one of these joints, like if I was to map this joint right now, this is what you get, right? It's just a little messy. It's a lot. And you don't want to come in here trying to find its connection to a decompose matrix. It's just a good way to organize your work is to save bookmarks. So I have the left and the right ankle visible. I'm going to add two decompose matrices. Add one here and there. And for me, when I'm using these nodes, I just want to make sure when I come back, I know what I used, because that's how you get confused. I think when I came in here the first time, I was confusing a mult matrix with a sum matrix. So the way I prevent that is I just leave the name that Maya gives me, and I just append it with a descriptor that lets me know what I'm going to use it for. So this will be the PSD, I'll call it PSD ankle fix on flexion. So let me be a little bit more descriptive. So I'll say PSD ankle fix on foot flexion, right? And you do want to use underscores. And I also do want another identifier to let me know it's the left side. So it'll be the left side. So PSD left ankle fix on foot flexion. I'll try to keep this same naming convention, and I'll copy this for the right side. All right. And the simple process of gaining access to these offset pair matrix values is just to grab the offset pair matrix parameter. It's not accessible just yet, so I'll go other and I'll search for it. There it is, offset pair matrix, and I'll pump it into this input field of the decompose matrix. I'll do the same here. Go other, offset parent matrix, and pump it in here. So now that I have these two decompose matrices set up to receive these offset pair matrix values, if I now go into my set driven key window and I was to load any of them, if I have this selected and I load it in as a driver, I now have access to everything, pretty much translation, scale, rotation. So all these are the offset pair matrix values. And what we are looking for is rotate Z, I think. So if I was to grab the left side and I look at what I have over here, it says minus 39 rotation. If I look at the decompose matrix, it has fed that exact value. So in this instance, we'll actually be getting exactly what the rotation is reading, and that's good. I thought it was going to convert it into some other type of rotation unit. So this is good that it's just the same thing. It's nice to be able to just identify it by just clicking back and forth a lot easier. So we're looking for output rotate value.